Yeah, so we are good to go. Okay, so some of the students are started joining in the YouTube. I don't know what is happening. Like in Zoom, students are joining. I think because there is a very less time span between both of them. So that's why I think students will take some time to join. Uh, like when it start because YouTube also running, so YouTube students also can have. Hello, Megha. Hello. So students have started joining. We will wait for 1 2 minutes, then we can start Sahana and Ashra. So because there is a very less time gap now, so that's why I think students are not willing to join, but will definitely they will join. So it's already 7 minutes. We can start. I think. Okay. So Ashra, can you hear me? Guys, like Sahana, Ashra, Sahana, Charlotte, Shruti, Amanda, India, Mahesh. These people all are joined.
Hello, good afternoon, everyone. May I start, sir?
Yes, you can start.
Yeah, thank you, sir. Good afternoon, everyone. I'm Sahana, presently studying at IIT Madras, Chemical Engineering BTech second year. I'm alumnus of Jawahar Navodaya Vidyalaya Hasan. I was guided under Avanti faculties. So happy National Girl Child Day. The significance of National Girl Child Day, like what's the significance of this? Like what's the need to celebrate this, celebrate this day? Because in each family, as we know, there will be a mother, sister, or anyone in the girl, like anyone, a woman or a girl. You can see the significance of their own importance of them in the family. Like you will get a good guidance, love from them, and many more. So what I wanted to say is like the empowering girls means it's an empowerment of the whole family. Educating girls doesn't mean the educating a single girl. It means that we are educating the whole family. So the program was introduced as Beti Padhao Beti Bachao. Why was that introduced? So like as a part of the society, we have our own responsibility to contribute to the society as we have taken many things from the society. So how can we contribute and what are the ways to contribute? you know, like this is a platform in Avanti Fellows. You're getting a lot of opportunity to learn things. Not only about studies, you may also get many guidance from them. You can see the way they teach and the way, like, everything. So what I wanted to say is make use of it. And how can you contribute to them? You just, nothing is there. You just work hard and achieve your goals. It makes it is the contribution actually what you're giving to them, the teachers. So what I say is just work hard. Achieving a goal is not a, like, not a joke actually. If you like, you have to study as if you are doing a tapas. It's not easy. Like achieving a goal is like a tapas, sitting for a tapas, and if you do, you'll really get what you want. So what I say is aim high, work hard. There's no shortcut for achieving some goal. If you get by chance also, it will not stay for longer. Because, like, as I learned from Avanti teachers, as they always taught us, like, hard work beats talent. If you work hard, surely the people who are talented and who are not working hard, you'll beat them one day, surely. So what I want is, like, study well, work hard as much as possible. Each and every person in this society has problem, in this world has a problem. But complaining your problem, regretting it, and like expecting things, so it's not a, like, it's not good. If you give more from your side, more from your side, work hard as much as possible, then you'll surely get. Because one day when you, like, if you like, think if you don't get your, like, what you want, so you can't blame the things, right? Like, what, this happened that day, this happened that day. No one is going to hear your words. So just not neglect, learn from your past, accept your failures. Like, don't accept it completely, like, learn from your failures, not accept it. Work till you reach your goal, and just accept everything, like, not as it is. At least you can make some changes where it is required, and accept everything. And you should bring up yourself as a motivated girl, as a model girl in the society, such that everyone will learn from you. You have to be morally, physically, mentally, emotionally strong. So I wish all the best to everyone, and please make sure that you're working hard, keeping a plan with you, and daily seeing it and making yourself stronger. Not only in terms of education or science or studying or something, but you have to be strong in everything, like physically, mentally, as I said. So, like, if you're making yourself strong, that means you're making your country strong, and you have to be responsible for it. So I wish all the best, and make use of the facilities given by Avanti. And we are now here because of them. I can confidently say that, because they have given so much things for us, and we have. I proudly say that I use it almost everything, every facilities they gave us, every opportunity they gave us. You have to learn to grab your opportunities and make use of them. No one will ask you if you have done, if you're not, if you don't do, or what happened, why you did not do. No one will ask. No one will come and ask. You have to just grab it and fulfill your dreams. That's all. And always be thankful to Avanti Fellows that are doing a great job, and work hard. Thank you.
Thank you, Sahana, for your words. Now, Asya, please continue.
Hello everyone. I'm Asya, first year MBBS. IMS Hassan. I studied in JNV Hassan and in Avanti Fellows. I want every one of you to take and make most use of it. Like, it's that females are more mentally stronger than male. Like, use that rather than regretting your problems and whining on it. Be proud that you are a girl. Focus hard, work on your dreams, be independent. Being a daughter of someone, being a sister of someone, make your own individuality, create your own identity, work hard for it. You'll always get help at any point. If you need it, ask for it. Ask to your mentors that you need help, get your doubts cleared, study hard. It's just now. Don't worry about anything else. Being failure is the next thing. Like, work hard for now, never regret later in your life that you could have worked hard and you could have done better. Just focus on now, work hard for yourself, for your identity, and for your life. Be responsible, handle it as a responsible. You are going to be adult. Take your responsibility of your life first. Be a responsible citizen. That's it. Study well. They'll help you out in any way possible. And happy National Girl Child Day to everyone. Thank you.
Thank you. Thank you, Asra. Thank you, Sahana, for your valuable suggestions to our students. So we are also very happy for being with Vignan. So I'm would like to thanks to the people who are in this meet. Then my the students are replying through the YouTube, and like it's very pleasure to meet you guys. So thanks for your valuable suggestions. Okay. Yeah. Vishal, shall I proceed with the class or do anyone is going to? Yeah. So Sahana and Astra, you can like share or you can leave. So whatever the people, whatever the suggestions you have given, that's very important for our students for sure. So and I hope you people will do great in your coming days. Okay. Yeah. That's it. Thank you. So then today's class we are going to start talk about Shruti Sharma is also with us. Shruti, you are from which school, ma'am? Is a coordinator or the student? Please tell me in the chat box. Shruti, you are from which school? So let me check through the YouTube transfer. Okay, Shruti, are you there, ma'am? So thank you so much for joining this session. And now I would like to start about the discussion which we have made in the previous classes. So that is basically we talked about galvanic cell and all. What is the setup? So you can clearly see. So this is the setup we have used. This is the setup we have used. Okay, that is anode. Okay. So whereas you can see here. So where the anode you are going to have the oxidation, right? So you can see here 0 to +2, it is nothing but oxidation state, that is losing of electrons will take place. On the other hand, for the copper cathode, it is going to consume the electrons and become copper on the surface of the cathode. So then we have seen a voltmeter, which is help us to calculate the voltage by connecting between these two electrodes. Okay. So now this is a voltmeter. Now the overall cell reaction will going to be like this. Zinc is going to be reduced as Zn plus 2 ions and Cu plus 2 will be coming as Cu. Okay. Yes. So hi Aditi Sharma. Please join the class. I don't know why some students are still. Okay. So we have seen this in the previous classes, and next we have talked about salt bridge. Basically, so salt bridge is a connection between two things, and we have seen about this one. So this is anode and this is cathode. So anode, the mass of anode will decreases for certain instance, and deposition of copper will take on the surface. Okay. So I also told you don't trick, that is left oxidation anode negative. So we have seen the net cell reactions. This is oxidation half cell reaction. It is represented like this. Okay, and this is a reduction half cell reaction. This is going to be represented like this. Okay, so now then we have seen this. Okay, this is the overall cell reaction. Okay, so now we can see that one. So the main functions of salt bridge you can see now. So this is the main functions of salt bridge. It is a inverted U-tube. It is a inverted U-tube containing chemically inert salt. So usually you are going to use the inert salts. That means they are not react with the electrolytes, but they are involved. They are helped for the conduction of electricity and maintaining the neutrality. How they are going to make? Because of the mobility of cation and mobility of the anion. Okay, na? And then we have seen about this one, where is we have seen about this one. It is usually you usually use it for the completion of the electrical circuit. So if you are not using the salt bridge, what is going to happen? So the zinc plus concentration on the left side will increases, whereas if you see Cu plus 2 ions concentration will decreases. So what is going to happen after some times? You are going to see only zinc plus 2 ions and here no copper ions. So in order to balance this issue, we are using the salt bridge. So it is also help you the maintaining the electrical neutrality, and it's also helpful in the spontaneity of the reaction. Okay, so spontaneity we are talking, that is delta G. Okay, you people need to remember. And next we talked about the salt bridge, this one, right? So the electrode potential developed between the, okay, the potential difference. Now we are talking about electrode potential. Electrode potential is nothing but the potential difference that is developed between the electrode and electrolyte interface is called as electrode potential. Okay, so it is usually represented by capital E. The potential developed, okay, during the oxidation is negative, hence the anode is having a negative potential. So you can also see that this is continuously losing ions. Okay, it is continuously losing ions and makes negative on the interface of the liquid. That is, electrons will going to be present on the surface of the electrode. Okay, so electrons will going to be present on the surface of the electrode. So that's why we can clearly say that negative polarity is developed at the anode. Whereas in case of cathode, you are going to see the positive polarity. That means we have seen that metal ions. In case of Daniel cell, we have seen copper ions will go and try to settle on the surface of the cathode, which brings the positive polarity. Okay, so next electrodes. Yes. So next we have seen electrode potentials are represented by capital E with the subscript. Okay, represent the process occurring like E anode and E cathode. Right. So now we have seen this one, oxidation potential. What is oxidation potential? Oxidation potential is nothing but the potential difference associated with the oxidation of reactions is called as oxidation potential. So you have seen that, let's suppose if oxidation is occurring, how do oxidation is occurring? Oxidation will take place at anode. So basically, if you have taken zinc for Daniel cell, so it is going to become Zn plus 2 plus 2 electrons. So that means what? 0. Zero to plus 2. That is increase in the oxidation state, that is plus 0 to 2. Okay. So that is increase in oxidation takes place. And then we can say that if we are maintaining some standard conditions, what are those standard conditions? Concentration is 1 molar, okay, and pressure is 1 bar, okay, and temperature is 298 Kelvin, okay. If you are maintaining these three parameters, then if you are maintaining these conditions, then we can also say that standard condition. And the electrode, if you are measuring here the potential, if you are trying to measure the potential difference between the electrode and the electrolyte, you are going to call it as standard electrode potential. And we can also say here oxidation is taking place, so that's why standard oxidation potential. Okay, so that is standard oxidation potential. It is represented like this. So for a half cell reaction, that is called as zinc says Zn plus fluoride. That is why zinc say Zn plus. So this is going to be represented like this. And next we have seen reduction potential. What is the reduction potential? Reduction potential where the reduction is going to occur. That is if you are having Cu plus 2 ions and it will consume 2 electrons and it will become Cu. Okay, na? So it is simply represented as E cathode. Okay, so that is nothing but what? Cu plus 2 and Cu. That is plus 2 to 0 bar. There is a reduce in the oxidation state. Okay, na? So the reduction potential measures concentration of all the species involved in 1 molar. Okay, the concentration will be 1 molar. Okay, and the pressure will going to become 1 bar. Okay, so if you are maintaining at the temperature at room, that is 25 degrees Celsius, whereas 298 Kelvin. So if you calculate the electrode potential, we are going to call it as standard electrode potential of cathode, or you can also say it is a reduction potential. Okay, so that's what you are going to call it as standard reduction potential. So now basically what has happened, standard electrode potential is involved at 1 molar concentration at 1 atmospheric pressure, 1 bar of pressure. So basically these are standard electrode potentials, right? So in as far as the IUPAC is concerned, standard reduction potentials are considered as to standard electrode potential to study on the common basis. Okay, so this is what we have studied, right? So the sign of oxidation and reduction potential for the same reaction are equal in the magnitude, but the opposite side. So it's very simple. So if the standard electrode potential value is plus 3.04, if you see plus say 0 horan. So if you are observing copper is going to become copper ion is going to become copper, that is plus 2 say 0 horan. So you are going to call it as plus 0.34 volts. Okay, so here this is actually reduction potential you are calculating, whereas in case of oxidation you can see 0 say plus 2 horan. So that is, you can say there is increase in oxidation number. It is called as oxidation copper. So if you want to know the oxidation potential of copper, you already know the reduction potential, which is 0.34. Just reverse of it. Okay, just reverse of it. You are going to get what? Oxidation potential, that is minus 3.0.34. Okay, and next you can see we have already talked about this one. And next there are some of the reactions where the oxidation reaction is taking place. So you can see 0 say plus 2 horan. So this is oxidation reaction, and this is plus 2 say 2 horan. This is a reduction reaction. Plus 2 say 0 horan reduction. So reduction, if it is given minus 0.07, so definitely oxidation need to be plus 0.76. If it is minus, that is wrong. So one has to give a negative sign for the electrode potentials. So if you are doing at oxidation, we call it as oxidation potential. If you are calculating the potential at reduction, we call it reduction potential. Okay. So then you have seen here Ag plus is becoming Ag, that is plus 1 says 0 horan. So you can say this is a reduction. Clear? So reduction, if you calculate the potential, you are going to calculate as reduction potential. So there are some of the IUPAC representation. You people need to remember what is how do you represent IUPAC? So anode, electrolyte, cathode. So we can also call it as cell representation. How do you represent the cell? Cell representation. You can calculate the cell representation, that is anode and electrolyte. So don't worry, don't write about anode and write as a cathode. Anode and cathode. So that means left side need to be anode and right side need to be cathode. Okay, and we already know that at anode, that is anode, oxidation is taking place, and at cathode, reduction is taking place. Okay, and the sign of anode is negative and the sign of cathode is positive. So if you represent, or if you remember these simple steps, then you can, whatever the cell they are going to give, whatever the reactions they are going to give, you are going to be represent in this particular fashion. Okay, anode and cathode. Okay, anode is always on the left side, that's why you call it as lone. Left oxidation, anode negative. So right side is nothing but RRCP, that is Rajasthan Royals won the first IPL Cup. That you can also say that. Right reduction, cathode positive. Okay, that's the basic sense we will be implement. So just now I am telling you. So we have taken the Daniel cell as an example. So in this case, 0 से +2 हो रहा है, right? It is 0 से +2 हो रहा है. So that's why we are going to call it as what? Oxidation half cell. And here you can see +2 से 0 हो रहा है. This is a reduction cell. And what we have observed, there is a 2 lines in between them. These 2 lines indicates salt bridge. Okay, so zinc is an anode, so that's why anode electrode, and this is anode electrolyte. So this is anode half cell and this is cathode half cell. You can also call it as oxidation half cell, and you can also call it as reduction half cell. You can also call it as reduction half cell, because reduction is taking place at cathode and oxidation is taking place at anode. Okay, I hope you people understand this one. So next we have seen at anode, you can see this reaction, that is oxidation is taking place. At cathode, you have seen this reaction, reduction is taking place. Okay, so now the reduction potential of anode is, you can also calculate like this. So the reduction potential of anode, you can also calculate like this: E left or EL or E naught L or E naught F or E naught left oxidation. So you can represent like this, that is oxidation, and you know that it's occurring at left side, and there is an anode is there, so you can represent like anything. Same in case of reduction also, reduction that is occurring at right side, and E naught is representing the standard conditions. E naught, if I am writing, means you are maintaining the standard conditions. Okay, that is the pressure is 1 bar, concentration is 1 molar. So then cell potential, what is cell potential? Cell potential is nothing but the potential that is occurring between reduction half cell and the oxidation half cell. So if you can calculate the cell potential, whenever if I say the name for cell, it is the complete system. So you have seen the anode and you have seen the cathode. So this is your anode and this is your cathode. Clear? So whatever the potential you are occurring here, this you call it as oxidation potential. Whatever the potential you are observing here, you call it as a reduction potential. So in order to get the net cell potential, in order to get the net cell potential, what are the things you have to do? Those you have to do is the C cell of that particular system is calculated by reduction potential of cathode and oxidation potential of anode. Okay, so but we already know that E reduction potential is negative of E oxidation potential, right? So that's why you are going to write as E reduction potential minus of reduction potential of the anode. E reduction potential of the anode. So ultimately E cell is nothing but E cathode minus E anode, or reduction potential of cathode plus oxidation potential of anode, or you can say that E right minus E left or E right minus EL. So my representation is E naught of cell can be calculated by E naught reduction potential of cathode minus E naught reduction potential of anode. So you just simply represent, remember this one. So it will help you like anything. Blindly go in your mind that whenever you are calculating the E cell, instead of calculating in terms of oxidation potential and reduction potential, convert everything in the form of reduction potential. So then you'll get to know that they are in the reduction potential, and you apply this formula, you can get the E of the cell. Okay, so that is what you need to remember. And next we have seen here. So illustration, if I want me to show the illustration, you can see here. Next I'm giving the question. So here you may see first what is happening. We have given a E naught Zn plus 2 Zn What is happening here? Zinc, okay, plus 2 electrons will become zinc, it will become minus 0.767. Okay, so zinc electrode potential is given. So you may observe here plus 2 से 0 हो रहा है. That means plus 2 से 0 यानी decrease in oxidation state. Decrease in oxidation represents reduction, right? So reduction is occurs at cathode, right? So indirectly he has given E naught of cathode, that is minus 0.76 volts. Whereas if you see Cu plus 2 plus Cu plus 2 and Cu, okay. So in this case also you can see here this is plus 0.34 volts, okay. So you can say that Cu plus 2 says Cu plus 2 plus 2 electrons reaches to Cu. Here this is also reduction potential. Here also reduction potential. So here also reduction potential. Here also reduction potential. But to avoid that confusion, we mentioned zinc is at anode. So we know that, and copper is at cathode. But we know the formula. E naught reduction potential is equal to E naught reduction potential of cathode minus E naught reduction potential of anode. And we know reduction potential of cathode is occurs at reduction, where the reduction process takes place, there only the cathode potential you can calculate. And anode is occurs at oxidation. So in this case, which is oxidation and which is reduction, that is copper is undergoing reduction and zinc is undergoing oxidation. So you need to write E naught reduction potential of Cu plus 2 Cu copper minus E naught reduction potential of Zn plus 2 say Zn. So if you can see in this case, so the reduction potential of copper is given, that is given as plus 3.04, and the reduction potential of anode is given minus 0.76. So if you calculate, so I will write the net cell reaction here. So that is E naught of the cell will become E naught of the reduction potential minus E naught of the oxidation and reduction. In case E naught reduction potential of, this is reduction potential, reduction potential of cathode minus E naught reduction potential of anode. So reduction potential of cathode is copper, so you know the copper value plus 3.04, okay, minus of minus 0.76. So if you add them, you are going to get 1.11 volts. So this is your Daniel cell voltage. What is Daniel cell voltage? That is 1.1 volts. I hope you people are clear with this. If you are clear, my dear YouTube friends, please do tell in the chat box. If you are clear with this, please do tell in the chat box. Okay, so I hope you people understand. If you calculate this one, you are going to get it. So now I have given you a question. So you have to solve this question. So how do you solve this question? So in order to solve this question, you need to know some basic idea regarding the equation. So you have seen Cu plus 2, okay, Ag plus 3 Ag oil, that is nothing but Cu gives rise to Cu plus 2 plus 3 electrons, and Ag plus 1 electron gives rise to Ag. So in this case, what is happening? This is, increase in oxidation state. So that's why this is oxidation. Okay, there is a decrease in oxidation state. This is a reduction. So oxidation always occurs at anode. and reduction is also a cathode. And to calculate the E naught of the cell, we will calculate E naught of reduction potential of cathode minus E naught of reduction potential of. Okay, so that's you people need to learn. Okay, so that is reduction potential, that is nothing but for silver 0.80 minus, whereas copper, if you can see, that is minus of 0.34. If you calculate 0.56 volts, you are going to get. Okay, units is important now. So if you are not knowing the units, then it will be. So you can see they also said that also write the half cell reactions, that is electron. And you can see here, here 2 electrons are involved, here 1 electron. So multiply with the 2. So then you are going to get what? Cu plus 2 electrons gives rise to Cu, that is Ag, plus 1 electron gives rise to Ag. But Cu plus 2 electrons gives rise to Ag. But this is the, but we have not given this one. We have given like this Cu plus 2. So Cu will give rise to Cu plus 2 plus 2 electrons. And as equal to, let us start. Cu gives rise to Cu plus 2 plus 2 electrons because this is oxidation. And next one is given Ag plus 1 plus 1 electron gives rise to Ag. And this is a reduction. Okay, so you need to multiply with 2, then it will become what? 2Ag plus and the 2 electrons gives rise to 2Ag. To write the net cell reaction, Cu plus 2Ag plus gives rise to Cu plus 2 plus 2Ag. Okay, so this is the net cell reaction. This is the reduction half cell reaction, and this is the oxidation half cell reaction. I hope you people understand this particular equation. Okay, so now let me tell you some of the another important point called as standard hydrogen electrode. What is standard hydrogen electrode? What is the purpose of standard hydrogen electrode? You will take a beaker. Okay, so you are going to keep one setup here, this particular setup. Okay, so this is completely filled with electrolyte. So basically I'm using HCl as an electrolyte. I am keeping 1 molar concentration. So then this is a tube where I kept a hole here. Okay, and I am passing H2 gas. I am passing H2 gas by maintaining 1 atmospheric pressure. Okay, so whenever I have kept this one, what I have observed here is like, so here this is platinum electrode. What type of electrode I am using? Platinum electrode. So I have observed platinum. Okay, and H plus is going to reduce as H2 gas. Okay, na? So I will write like this. This is called as cell representation for the standard hydrogen electrode. So what is happening in this one? What is the purpose of this one? So this SHE is helpful to predict the unknown electrode potential. Okay, SHE is help us to give the unknown electrode potential. Okay, so whereas second, if you can see, electrode is used to calculate unknown electrode potential, whereas it is also called as standard hydrogen electrode because it is maintaining at 1 molar and 1 bar pressure at 273 Kelvin. Okay, so SH is used for that. So this is the cell, and if you write the cell reactions are very amazing. That is 2H plus 2 electrons gives rise to H2. Okay, this is nothing but reduction. Okay, so another one is nothing but H2 gives rise to, next one is H2 gives rise to 2H plus 2 electrons. Okay, this is nothing but oxidation. So you need to remember. So the E naught of H plus and H2 is equal to 0. Always send at 0. Okay, so standard hydrogen electrode is used to calculate the unknown metals electrode potential. Unknown metal, yani let's suppose before that, you can't say the electrode potential of copper, zinc by its means. So in order to know the potential of different metals, just connect with the standard hydrogen electrode and see in the monitor what is our voltmeter. Then you will get to know the electrode potential of the unknown metal because you are assigned 0 for standard hydrogen electrode. So definitely it will given unknown methods when we calculate by using this standardization electrode. Okay, I hope you people understand. Okay, so that's it, guys. Sorry, power cut is there. Okay, thank you so much.